we bought actually a big enter button. And once we have, it's like a gong. So once we're finding vulnerability, we are pressing on the enter. So it's like a gong.
Welcome to 20-Minute Leaders. Just sit back, relax, and learn from the leaders of today. It's a journey. Each one is different, unique, inspiring. Let's get started. This episode is powered by J Ventures, a community-driven VC fund in Silicon Valley, in partnership with Lomitech, and sponsored by Homeward Ventures, Hippo Insurance, Upwest, Hillel at Stanford, Leap, and Birthright Excel. Let's talk about what it's like being a security researcher, a vulnerability threats researcher. Meet Sharon Brizinov, Vulnerability Research Team Lead at Claroty, where his focus areas are critical infrastructure systems, IoT devices, and malware analysis. Under his guidance, the Vulnerability Research Team at Claroty has found and disclosed more than 200 vulnerabilities, most of which have been patched or mitigated by the affected vendor, improving the safety of the ICS domain and critical infrastructure sectors worldwide. Sharon has also participated in well-known hacking competitions such as PWN2Own, and he owns a DEFCON Black Badge for winning the ICS CTF contest. Okay, Sharon Brizinov, welcome to 20-Minute Leaders. How are you?
Hey, thank you very much. I'm great. How are you, Michael?
I'm doing great. Thank you so much for being here. Today you run the vulnerability research team within Claroty.
That's right.
And that sentence is so cool in itself. And while, I come from a little bit of a cyber background, and so I understand a little bit about what you do, I find it so cool, and I'm so excited to get to speak to you in these 20 minutes and share, this passion with the rest of my friends and colleagues, because being a security researcher is not trivial. The process is not trivial. The things that you experience is not trivial. And so I'm really excited to get to know you better, the way you think, but also the life cycle of discovering these threats, what happens before, during, and after. So Sharon, take me back first a little bit to your childhood. How do you get to become a threat or vulnerability researcher?
Yeah. Okay. So that's actually a very funny story. When I was a kid, I was really fascinated by the culture of the hackers. So I remember watching. I don't remember exactly at what age it was, but I think it was around 6 or 7. I saw Matrix for the first time, and Matrix is the movie about hackers. So they're kind of hacking the Matrix, which is kind of a virtual platform that humans can connect with machines through the Matrix. And I remember watching this, and I was just fascinated. I thought hackers were so cool. They had guns and they did a couple of cool stunts, and I was just amazed. So it took me a couple of years to understand that hackers is just it's not really about action movies, rather hacking computers and typing fast on the keyboard. But this is what caught me, the interaction with computers, so you can change the reality inside a computer. This is what fascinated me from a very early stage.
I love it. And so how do you act on that fascination? So you're at an early stage, you realize you're fascinated by these questions. What do you do then as a kid? How do you sort of feed your curiosity with that?
Yeah, so it's a good question. So I received my first computer at the age of 8 or 9, something like that, and I immediately started to wonder how it's working. So what is a CPU? What is RAM? How do you interact with the computer? How do you create programs? So very fast, I started to create my own C programs, and I started to interact and create some very simple Hello World style programs. And it was so cool that I was able to create my own creations using the computer. So I developed a calculator so I could calculate how much is 2 plus 2. And I was just fascinated by the fact that I can create my own products. So this was my first interaction or my first introduction with the computer world. And with time, I was intrigued and was very interested to understand how the computer really works. So I invested a lot of time in understanding how can I write programs in assembly and Python, in PHP, other languages. And I started to develop my own websites, my own programs, and this is how I really got fascinated and intrigued into the computer world.
Mm-hmm. And so if you fast forward today to the position of a vulnerability researcher.
Yeah.
Dumb it down for me. What does that mean?
Okay, so it's a great question. So we are vulnerability researchers. This means our goal eventually is to find vulnerabilities and disclose it to the companies so they could mitigate the vulnerabilities or remediate them. So what we're doing is we're trying to understand and think what are the most common platforms that most people or factories are using. So I'm coming from a SCADA background, which means, as you can see in the background behind me, this is our lab with lots of OT and IoT equipment. This is actually a critical infrastructure equipment that is the brain behind critical infrastructures such as gas distribution, oil distribution, electrical distribution, water facilities. So these are PLCs, these are the controllers that are actually the fundamental, the brain behind any critical process. And so we try to understand what our customers are using, what are the most common platforms in those critical infrastructures, and we want to make sure they are not vulnerable, so attackers could not break into them. So what we're doing is we're getting these devices, we're setting up all of them in our lab, and we're trying to poke around and understand how they're working, what the setup is looked like, and how can we find vulnerabilities in them. So what we're doing to do that, so we're trying to kind of break them. So we're taking the hardware apart, we're taking the firmware, so we're starting to investigate the firmware and analyze what are the attack vectors that potentially attackers could abuse in order to infiltrate into these devices. So for example, if we're finding a vulnerability in the firmware, we're trying to exploit it, which means we're trying to create a POC that will actually use this vulnerability to the attacker's benefit. And with this vulnerability at his hand, they will be able to achieve code execution. So they will be able to take fully control on this device, and from there, they could affect the process. So for example, they could change the temperature of the water, or they can change the amount of electricity that is allowed to be distributed. So this is kind of the thought process and what we're doing in our lab and in our daily routine at Claroty.
Right. So I think that brings me to a really fascinating idea. You know, most people that are working in the tech place or in the tech ecosystem, you know, they have a task. They know that they're going to be developing it. They know that there is going to be a deadline for that task, and this feature is going to be deployed, and these are the KPIs. You don't really have that. You don't have the luxury of saying, you know, we need to find the vulnerability by tomorrow. You know, sometimes you don't even know if there is a vulnerability. Exactly. We assume there is, but how do you mitigate, you know, sort of the uncertainty behind the life cycle of finding these vulnerabilities?
Yeah, it's a really good question. So researching is all about the unknown journey. So you get a device, you start poking around, but you don't know really when you will finish this journey. So what we're trying to do is, before defining KPIs for each project, we're trying to understand what are the attack vectors. So once we have the device, let's say we know it has a network capabilities or it loads files from certain places, we're starting to understand what are the attack vectors that attacker could potentially attack and exploit. Once we have the attack vectors, we're trying to assess how much time we will need in order to reverse engineer the entire, let's say, the entire platform or the entire attack vector functions, so we could have a better understanding of how the device is working and how potentially the attacker will attack the device. And once we have all the information that we need, I mean, all the assessment is complete, then only then we're defining KPIs of how much time it will take us to find a vulnerability, if it exists or not. And so we're scoping this in a very specific time frame before declaring there are no vulnerabilities or finding vulnerabilities and moving on to the next project.
That makes a lot of sense. Now, once you find a vulnerability, how does that work? You find the vulnerability, you mentioned that then you run the POCs, you sort of put the red team head on and you want to see, okay, what can we do with this? And let's say that you found something crazy, you found something insane, like being able to change to run code that changes the amount of electricity that is now being distributed. First of all, beyond, what happens in the professional world, what is the reaction within your team as the team leader, from a leadership perspective? How do you manage this now reaction and the either excitement, stress, whatever it may be?
Yeah, so every time we find a vulnerability, specifically remote code execution, we're very happy, of course, because it means we're doing our job right. And so we bought actually a big enter button. And once we have, it's like a gong. So once we're finding vulnerability, we are pressing on the enter. So it's like a gong. And yeah, there is a lot of excitement, and we're very happy because it means we're doing our job right, and we have brilliant researchers. And actually, up until now, we found around 250 vulnerabilities. So that's quite a massive number. And after we find a vulnerability, we're disclosing this to the appropriate vendors. For example, Microsoft is a vendor, Cisco is a vendor, Rockwell, Schneider Automation is a vendor. So there are a lot of vendors in this ecosystem. And we're disclosing the vulnerability to the vendor, which means we're creating a POC that reproduces the exploitability of this vulnerability. And we're writing a short report with all of our findings, and we're sending this to the vendor. Usually, big vendors are very happy to receive reports from researchers because it helps them to mitigate these vulnerabilities. So it helps them to make their products more secure. So they're happy with this. And so we're working with the vendor, we're disclosing all the information to them, and we're working with them so they sometimes ask for our advice, how should they fix the vulnerability. And for a couple of months, we're communicating and working with them to remediate the vulnerability. So once the vulnerability is remediated, usually the vendor issues fixes or patches to its customers. And only then is when we're assigning a CVE. So a CVE is like an identification number for the vulnerability. So all the asset owners could have the knowledge of what they need to do if they're vulnerable to this CVE or this vulnerability. And usually what they need to do is to patch and upgrade it to the new release. So basically this life cycle of researching, finding vulnerabilities and disclosing to the vendor really helps and improves the entire security of the whole market. So vendors are enjoying this benefit of receiving free reports from security researchers, and asset owners are safer because other attackers could not exploit these vulnerabilities because they have been patched.
What are some leadership challenges that you may face, or one may face, as they're leading a team of researchers that obviously it requires different leadership management and styles than managing a traditional business team or a traditional team of even just engineers? What kind of skills or challenges are you faced with in your day to day?
Yeah, so it's a good question. I really think that leading a team of vulnerability researchers is quite different from leading a team of developers because these are hackers, and hackers do not like to play by the rules, which means you need to be very creative with how you manage them and how you work with them on a team. So usually it's not like boss and employee. It's more like working together towards achieving a goal. And we must be very creative when we're working together as a team, because finding vulnerabilities means we need to bypass some security mitigations. So we need to be very creative when we're doing that. And so I think that the biggest challenge is to know how to work with hackers in a team and be creative together.
So is it mandatory sort of that you are one of them? Do you think that somebody who's not a hacker, who isn't able to do the work that you're doing, could they be a successful team leader, an intimate team leader of such an organization?
So it really depends how independent the security researchers are. There are some security researchers that like to play along, so they're lone wolves, and they receive a task, find vulnerability in this device, and they will do anything in their power to achieve this. But when you're doing vulnerability research at scale, so we have here hundreds of devices and we're finding vulnerabilities at scale of hundreds, we need to be very efficient and we need to have lots of manpower and working together so we could accomplish this task.
That makes a lot of sense. What do you enjoy most about your work? Is it the before, during, after, altogether?
So I just love the entire process. I love it how I need to be creative and push my boundaries every day to find new vulnerabilities, because vendors are fixing vulnerabilities and we still need to find vulnerabilities and bypass their security mitigations. And I really enjoying working with vendors and actually see how they think, how their developers and engineering teams are thinking about security. And I like the interaction of a security researcher and a developer or engineer working together in order to create the most secure devices in the world. So right now I can say with some confidence that because of our innovative research, I do know that the SCADA world and the OT and IT devices are much, much, much more secure. So I really enjoying the fact that we can shape and make some influence on the security state of in the entire SCADA market.
So obviously, when you're approaching a company or a vendor and you share with them a vulnerability that you found, especially one that allows one to run remote code, there's a big, it's a positive idea that you did because you found it and hopefully before anybody was able to exploit it. But what is the initial reaction like? What is sort of the reception that you get from a company and it's like, oh shoot, we have a problem on our hand? Is it shock? Is it, anger? What kind of feedback do you get?
Yeah, so it really depends actually the size of the company. Big companies are well adapted to this kind of situation that they're receiving security reports from researchers. But smaller companies that it's their first time are very hesitant. So I have a funny story. We found a vulnerability in a PLC, which is a controller for a critical infrastructure. And we reported this for the first time for a very small company, relatively small company. And they could not understand why we're using our free time and sending them information for free. So they thought we're trying to blackmail them. So it was a very kind of funny interaction where we tried to explain them that we're security researchers and we're doing this for the community and for the benefit of the entire market. And so it took them some
unbelievable.
Yeah.
I love it. Where does a security researcher, in your eyes, draw the inspiration or creativity? Is it from reading, from different reading sources, remaining up to date? Where is the inspiration coming from to have this ingenuity to go and try all these different things?
Yeah, so as a security researcher myself, I can say that as a kid, I drew my kind of motivation from movies, hacker movies. And today I'm drawing my motivation from great security researchers around the world and from CTFs. So CTFs are kind of hacking competitions where you need to hack devices and software to achieve flags. And I really enjoy playing CTFs and hacking competitions myself. And I think it really improves my skills and improves and supports my motivation towards this subject.
Amazing. And where, in your eyes, is the world going with this? So, do you think that this model is the right way to go? That we have a lot of vendors, and then we have these small security teams that are going to be researching the vulnerabilities. Are we going to have more vulnerability researchers as time moves forward? How should the world adapt to the need that you're observing today?
Yeah, so it's a good question. In modern companies, you don't have just developers or engineers. You have developers or engineering team, and you also have a security team or red team that are poking around internally on the product, because developers or engineers need to be focused on developing fast their products. And sometimes they have some oversights and they're doing security mistakes, but since they wrote the code, they don't have the option to make these observations towards security. So that's why they need external entities or internal red teams to do this kind of job. And I do think security researchers like us that are doing this across the entire platforms are very a necessity in this ecosystem, because with the IoT world, so you have lots of devices Your refrigerator is connected to the internet. Everyone can connect to everyone, to everywhere. You have lots of devices, and you need someone to poke around and make sure vulnerabilities are found and mitigated before attackers would do that.
I love it. And Sharon, all this is in the context of, literally, we're talking about companies, and one of the things I love most about the show is talking to people that are making a positive impact on the world. And, immediately when you hear about a team that is that is doing vulnerability threats research, you don't immediately think of, the positive impact, but the truth is that it's life-saving, and that, the work that you're doing, you're dealing with the hardware, with the connected devices that are then, the things that are powering our hospitals, that they're powering the world, all this infrastructure. And so obviously these vulnerabilities can be life-threatening. And so by mitigating them, you're actually life-saving. And I think that the context here is important. And a lot of people need to thank people like you and teams like yourselves for the work that you're doing. And Claroty is an amazing company by an amazing organization. And so it's, you already have a big fan here. And I really want to thank you for your time. This was just inspiring and really, really fun and interesting. And thank you. Stay safe and stay healthy.
Yeah, thank you so much. It was such a great time. Thank you.
Thank you
very much, Miguel.